Hello everyone. Today we will going to see some practice questions from the topic electrochemistry, and this is part 2. Let's start. Disclaimer which says the images used in our slide deck are for educational purposes only. We respect the intellectual property rights of original creators and owners of these images. If you are the owner of any of images used in this deck or have any concerns or issues, please contact us at sathee@iitk.ac.in and we shall remove the images. This is index slide and we will going to see practice questions from question number 9 to question number 60, one by one. Let's start with the question number 9. A current of 2 ampere is passed for 5 hours through a molten tin salt to deposit 22.2 gram tin. What is the oxidation state of tin in the salt? We have to find out the oxidation state of tin. Atomic weight of tin is given. Tin symbol is SN, 118.69 gram. Options are +2, +5, +3 or +4. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, let's see the answer. The correct answer is option A, that is +2. So equivalence of tin is calculated by this formula, that is I dot T divided by F, 1 Faraday value, which is 96500. Now equivalent of tin will be the weight of the tin divided by equivalent weight, that is 22.2 divided by equivalent weight is equals to 2 ampere current, and 5 hours is the time, so we convert it into seconds, so we multiply it by 3600 divided by 96500. So equivalent weight coming out from this equation is 59.5. So the valency of tin will be, equivalent weight is atomic weight upon equivalent weight. Valency of tin will be, valency of tin is atomic weight divided by equivalent weight. Atomic weight is given 118.69 gram. So 118.69 divided by equivalent weight, which is 59.5, and it is coming out as equivalent to 2 approx, which is an integer, because valency should be in integer form, right? So it will be equal to 2. Therefore, the reaction of oxidation of therefore the reaction for the tin will be Sn2 positive plus 2 electron, giving us Sn. So from +2, Sn +2, it is going to Sn0. Reduction is happening. Thus, oxidation state of tin in its in the salt is +2, as you can see here. Okay, so the final answer is option A, that is +2. Okay, let's move to the next one, that is question number 10. In the electrolytic cell, flow of electrons is from. So remind the concept of electrolytic cell. We have to tell the flow of electrons is from which to which, from where to where. Options are cathode to anode in the solution, cathode to anode through external supply, cathode to anode through internal supply, anode to cathode through internal supply. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, let's see. The correct answer is option D, that is anode to cathode through internal supply. So basically, in electrolytic cell, the flow of electrons is possible from anode electrode to the cathode electrode through the internal supply. Okay, this is the basic concept of an electrolytic cell, and thus option D, that is anode to cathode through internal supply, is the correct answer. Okay, let's move to the next question. Question number 11. When the sample of copper with the zinc impurity is to be purified by electrolysis, the appropriate electrodes are. We have to remember the concept of the electrodes and the purification. So we have a sample in which we have a copper, we have a zinc impurity. we have to purify this by electrolysis. So what kind of appropriate electrodes we should use? Options are: the cathode is pure zinc, anode is pure copper. Cathode is impure zinc, anode is pure copper. Cathode is impure zinc, anode is impure sample. Or cathode is pure copper, anode is impure sample. So you have 10 seconds to solve this question. After that, we will see what will be the answer. Okay, let's see the correct answer. That is option D. So cathode should be pure copper, anode should be impure sample. So impure sample is made the anode, and pure copper act as cathode in the process of purification of zinc impurity by the electrolysis process. Okay, thus option D is the correct answer. Okay, let's move to the next question, that is question number 12. So lambda naught M NH4OH is equal to, options are lambda naught M NH4OH plus lambda naught M NH4Cl minus lambda naught M for HCl. Lambda naught M NH4Cl plus lambda naught M for NaOH minus lambda naught M for NaCl. Or lambda naught M for NH4Cl plus lambda naught M for NaCl minus lambda naught M for NaOH. Or lambda naught M for NaOH plus lambda naught M for NaCl minus lambda naught M for NH4Cl. So you have to choose the correct option, which will be equal to lambda naught M for the NH4OH molecule. You have 10 seconds to solve this question. After that, we will see the answer. Okay, let's see the answer. So the correct answer is option B, that is lambda naught M for NH4Cl plus lambda naught M for NaOH minus lambda naught M for NaCl is equals to lambda naught M for NH4OH. Let's see how. So according to Kohlrausch law laws give us that the molar conductivity or the molar conductivity of any molecule should be equal to the sum of their ionic molar conductivity, right? Like we can write it in equation in that form. So what we have to write? We have to write the lambda naught M for NH4Cl plus lambda naught M for NaOH. Okay, this will be equal to lambda naught M for NH4OH plus lambda naught M for NaCl. Because if you perform a reaction, if you give a reaction here that NH4Cl plus NaOH will give us NH4OH plus NaCl, right? So for any reaction, we can write their the compounds or the molecules molecular conductivity in the form of their sum of their constituents or products or reactants molecular conductivity, right? So this will be the reactants NH4Cl and NaOH. This will be the product NH4OH and NaCl. So we can write the molar conductivity in this form, that the molar conductivity of sum of molar conductivity of reactants should be equal to sum of molar conductivity of products. Okay. So what we have to find out? We have to find out the lambda naught M for NH4OH. And in this equation, we have this here, lambda naught M for NH4OH. So we will take it here only, and this will go here, and plus will become negative. So lambda naught M for NH4OH will become equal to lambda naught M for NH4Cl plus lambda naught M for NaOH minus lambda naught M for NaCl molecule. And this is the final answer, and thus option B is the correct answer. Okay, let's move to the next question. Question number 13. For the reaction, half of H2 plus AgCl giving us H positive plus Cl negative plus Ag occurs in the galvanic cell. So we have to tell that this reaction is happening in which of the following galvanic cell? given in the option, right? We have to choose the correct cell diagram. Options are Ag, phase division AgCl, phase division KCl, salt bridge AgNO3, phase division Ag. Platinum H2HCl, salt bridge AgNO3, Ag. Platinum H2HCl, salt bridge AgCl, Ag. Platinum H2KCl, salt bridge AgCl, Ag. So you have 10 seconds to solve this question. After that, we will see the correct answer. Okay, so let's see the correct answer. That is C option. So this representation of the cell for this reaction in the question is the correct one. So H2 hydrogen undergoes oxidation and AgCl, or you can say Ag positive, undergoes reduction. Okay, therefore cell may be represented as platinum H2 HCl, salt bridge AgCl, and Ag. Okay, so this will be the representation because H2 is undergoing oxidation, so it will be on this side, left hand side, and salt bridge AgCl or Ag positive is undergoing reduction, so it will be on right hand side, and this will be the correct representation of a cell reaction or the cell. So thus option C, having the correct representation, is the correct answer for this question. Okay, let's move to the next one. That is question number 14. Which of the following is not true? We have to select among the options that which option is not the true statement. So options are: cathode is negative terminal in an electrolytic cell. Anode is positive terminal in a galvanic cell. Reduction occurs at cathode in either of cells. Oxidation occurs at anode. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, let's see the correct answer. That is option B. So anode is positive terminal in a galvanic cell. So this is the statement which is not true among the option given. So in galvanic cell, cathode is positive terminal and anode is negative terminal in the galvanic cell. But as in the option B, it is given that anode is positive terminal in a galvanic cell, which is not true. And thus this is the correct answer. Option B is the correct answer. Okay, now let's see the next question. That is question number 15. The standard reduction potential for Fe2 positive Fe and Sn2 positive Sn electrodes are minus 0.44 and minus 0.14 volt respectively. For the cell reaction Fe2 positive plus Sn giving us Fe plus Sn2 positive, the standard EMF is, we have to find out the standard EMF E0. For this given cell reaction, we have given the standard reduction potential for each of the electrodes. Okay, options are plus 0.3 volt, minus 0.58 volt, plus 0.58 volt, or minus 0.3 volt. So you have 10 seconds to solve this question. After that, we will see the correct answer. Okay, let's see the correct answer. That is option D, that is 0.30 volt. So it is given that E0, the standard reduction potential for Fe2 positive to Fe, will be equal to minus 0.44, right? And E0 for Sn to Sn2 positive will be plus 0.14, because we have given the standard reduction potential for Sn2 positive to Sn, because reduction is happening in this way, right? 2 positive to 0. Sn is going from 2 positive to 0. So it will be minus 0.14. So if we reverse this, it will be E0 for Sn2 SN2 positive, this will be positive 0.14 volt, right? And E naught of cell is equals to, so E naught of cell is equals to E of cathode minus E naught of anode. Okay, cathode minus anode. So cathode, for the cathode it is given 0.44 negative, minus for the cathode it is given minus 0.14, right? So minus of 0.14, minus will become plus, and plus minus will become negative. That means you have to subtract from this to this, and as 0.144 is the greater one having negative sign, so the answer will be negative sign, so it will be 0.30 volt, right? And thus option D is the correct answer. Okay, let's move to the next question. Question number 16. Of the following metals that cannot be obtained by electrolysis of aqueous solution of their salts are. So if we do the electrolysis of the aqueous solution of the salts of these given elements of in the option, so which of the following metals cannot be obtained through this process? Okay, we have to tell this. Options are silver and magnesium, silver and aluminium, magnesium and aluminium, copper and chromium. You have 10 seconds to solve this question. After that, we will see the answer. Okay, let's see the correct answer. The correct answer is option C, that is magnesium and aluminium. So magnesium and aluminium cannot be extracted by the electrolysis of their aqueous solutions. This is because their reducing potential or reduction potential are negative. Okay, so magnesium and aluminium have lower reduction potential than water because they are negative. Hence, H2 is reduced more easily to give H2 gas at the cathode rather than using magnesium and aluminium. Okay, thus option C is the correct answer, that is magnesium and aluminium.